Okay, I suggest we continue. So we have now 1.5 hours up to the afternoon tea break. And after that, we'll have a lecture and some practicals by Stephen Brown. And he will go into the details as to how to customize the plots to convey the right information, what kind of colors to use. As you will see, I will produce some truly horrible figures this afternoon and tomorrow, at least by these standards. So I'm going to create, I'm still in my project directory here. Oh, I forgot. I need to write a note before. To add an archive with all the data files on the Google Drive. Because apparently at least 2 people had an issue with the ALL dataset with download file, and then downloading they weren't able to load it into R. I'm not sure what the issue is. It shouldn't be an R compatibility reason. But anyway, so I'll copy these into Google Drive later on. Anyway, so second session, so I'm going to create a new script. And I'm going to say immediately as S02, I'm going to call it ggplot because that's one of the things we're going to do. But actually before ggplot2, we're going to briefly have an overview of dplyr. Deploy ggplot2, and then I'll give you time to do exercises. So I'm going to start by loading the tidyverse and all the packages that we will need later on. And so the first thing that we're going to really briefly review are the kind of 4 basic manipulations that we can do on these long and tidy tables. So here is one example thereof, and that would be the IPRG dataset, the first one that we loaded, with 7 variables and 32,000 rows and so on. So typically there are sets of operations that we want to do on these datasets. And one would be to select some variables of interest. So variables are always along the rows, and my observations are always along. So I just say rows, and then my variables are always along the columns, and my observations are along the rows. I don't remember what I said, but I'm sure you have translated. And so if I want to do the selection, some variables of interest, this is something that I would do with the select tidy tool. Tidy because it takes a tidy data set as input. The tidy data set has some expectations. If these are not met, nobody what's going to happen. It will depend on the data set. But assuming this is a tidy data set, the output of select will be another tidy data set with the appropriate variables retained. On the contrary, what we are interested in are a set of observations. For example, here, this is an operation we would do with the filter function. Again, it's a tidy tool. It accepts to have tidy data as input. If the data is not tidy, again, nobody knows what's going to happen, and that will be data dependent. So select variables, filter observations. Another operation that we might want to do is to add new variables, and that's something that we would do with the mutate mutate a function. And so actually what we're going to see this afternoon as our set of tools. So we have seen, let's say basically 3 data structures, the long ones, the wide ones, and these omics containers. And what we're going to do this afternoon and the whole day tomorrow is to learn about the set of tools. This afternoon and tomorrow, also whole set of tools, using a very general term of what can we do with this data. And these different tools will work on different types of data. And now we start with the kind of the most general tools, which are dplyr and ggplot2, and these work on tidy data sets. And what we're going to see tomorrow, for example, if we want to do PCA analysis, we don't need to say that there's surely a tidyverse-like PCA function, but the kind of low-level PCA function doesn't care about tidy tools. It wants data in a certain format, which would be the wide format. And so again, we need to be able to move from one data structure to another. Carrying on here, we select variables, we field observation, you mutate a tidy data set to create new variables. And the last operation would be, commonly used operation, is to split a data set based on the variable. So for example, if here we have some categories, A, and then B, 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 these of course don't need to be ordered like this. We want to group a data set based on a variable to have 2 subsets, subset A, subset B, and then do some calculations, calculate some summaries on these 2 subsets, 2 data sets, and then bring these back together as a kind of a summary result. And this would be done with 2 other functions. The splitting is done with a function called group by, and the calculations of the summaries and combining these is done with a function called summarize. Cool. So a set of 4 tools that we need to be able to use to produce all sorts of visualization, and these tidy data sets that are always produced with these tools are exactly what we need to feed into R. So I'll make sure I still have my PRG data set. I do. Okay. But I'm going to quickly copy this. So in case you don't have the IPRG data set ready, here is the line of code that you can run to obtain this long data table. So let's explore the filtering, selection, and so on. So here's the IPRG data set. So if I was interested in selecting, for example, protein and condition, this is how I would execute this selection. If I was interested only in observations, still in my IPRG data set, that have a condition equal to condition, I would apply my filtering by specifying this expression. And by the way, what I need to feed in here is any expression that will generate a vector of logicals of appropriate length. And by appropriate length, here what I mean is equal to the number of rows of my input data frame here. So it happens that with the filter function, condition equals equal condition, we automatically look for the variable condition inside this table or data frame. But I could also use other expressions here And these would work as long as their output is compatible with the number of rows in IPRG. At least in my opinion, a great benefit of using these tools, tidy tools that expect one specific type of object as input and return that very same type or class of object, is the possibility to use piping. So for example, if I want to do some filtering and some selection from my IPRG data set, here, I can use the piping, start with my IPRG data set, and for example, pass it into the filter function and retain only the observation that match condition 1. Okay. So this works and is exactly equivalent to line 9. Not a great benefit here, but once we start chaining additional tidy tools, then I think that the pipe really shines. And here, for example, I can now immediately select, for example, protein condition. But note that, and I'm not sure if I have these examples for tomorrow. If not, I'll try to prepare one. But note that this piping is not limited to the tidyverse and Tibbles. Piping works for any type of object. So for example, CRC, which is in a Zen set, we can, and for example, there is the pdata function that will extract, or the XPRS function, which are simple accessors. We can also use the piping here. Okay. So piping is not limited to Tibbles, but piping works for any function that takes as first input an object of a certain type and then returns that same object as output. So piping also works with the omics data containers. As long as the functions respect this contract, I get one object as input and I get the other object as, or same type of object as output. Yes?
Does it always produce a Tibble as output? And can you ever have it produce a data frame as output?
Oh, okay. So Tibbles and data frames are the same thing. Tibbles are cute versions that are printed nicely. But these will also work with data frames and Tibbles. So you could have a function that takes a Tibble as input and returns a data frame.
Okay. I mean, the reason I ask is that Tibbles no longer supports row names. So for some of these tiny functions, you can just drop the row names. But I didn't know if there's a simple way of avoiding that problem.
You could use data frames. You could ignore Tibbles and simply use data frames, and they will. A Tibble is a data frame with an additional bells and whistles. Note that one of the functions here could not return a Tibble or a data frame, and that's of course possible, but then you kind of break the chain. If it doesn't return, if it's not endomorphic, non-morphic function is a function that takes a certain time object as input and returns the same type, then we kind of break the chain, and we cannot continue chaining operations without necessarily looking at the output and knowing exactly what it is. So I'm going pretty quickly over this because based on the survey this morning, you all seem pretty familiar already with these concepts. But if you have questions, of course, don't hesitate to stop.
I have a quick
Yes.
comment. So I just tried it with an ordinary data frame, and it seems, well, tidyverse works by first coercing any regular data frame to a Tibble, and so it seems that you do lose any row names. It seems like the tidyverse is strongly encouraging us to not use row names.
think that depends on the functions. Unless maybe it has changed, but some of these also return coerces back. But
It does coerce back to a regular data frame.
But you use names. Okay.
Yeah, and use the names in the process, the row names in the process.
That's actually really annoying.
I know.
And that's why in IPRG, what is it, 2? The third one, when we converted from the long to the wide data set, we still had the protein here, and somehow it's expected that this information, row names, in the tidyverse is encoded as a variable. I personally think there is somehow a conflict between the tidyverse, which is really useful for some things, and then maybe other approaches.
Tidyverse really wants you to do things their way.
Yes, yes, absolutely. And for a good reason why it works really well, and that's the reason for their success. But sometimes there are these conflicts like row names, yeah.
Yeah, they do say it's opinionated set tools.
Yeah. So let's move to the last one of interest, so mutate. Let's say we want to have a intensity. And so this is going to be the name of the new variable that we create. And here I can write a normal expression. Let's get my variable name right here. And to create here a new variable that is based on one that already exists. Okay. And to finalize the last important two things I want to do is the group by function. And so let's, for example, group it by condition. So the IPRG had the 36,121 rows and 7 variables. After grouping it, it's still the same data set, so the data set as such doesn't change. What is done is that there is an additional attribute that is added, saying that actually this long table is grouped into 4 groups, 4 parts based on the condition variable. And under the hood, what happens is that these indices for the groups are stored. And now we can start to ask new questions that will be applied to these 4 different groups. And for example, we could ask the mean intensity is equal to the mean intensity here. And so this is still a tidy data set. It's of course completely different than the one we had before, because given this grouping and this summarization, log 2 intensities, RONs, all these have been dropped because they don't make sense anymore under the light of this new data set. But it's still a tidy long, although it's not very long here, but a kind of long and tidy data set that can be used as it is directly into ggplot2. And we don't necessarily need to limit ourselves to one summarization here. We can calculate as many as we want, and these will be added as a new variable in our output. And the last function here, also that follows, also group by, and one that I think is needed for some of the exercises later on. Okay, I'm still going to say group by condition, and this one will be a tally. It's going to count how many observations I have in my respective conditions. And we see here indeed that I have one that is missing in condition 4 and 2 in condition 1, but this corresponds to the missing values that we identified earlier on in the morning And we actually identified these because we transformed them into a wide data set. And then that's when we realized that we had missing values. Any questions here? So let's move then to ggplot2. And for ggplot2, apparently here I use not a data set. Oh no, it's the same. It's the same. So ggplot2. Whenever we want to plot anything with ggplot2, we start by running ggplot2, and ggplot2 doesn't do much except being made aware that we're going to plot any data set with ggplot2, and that's also kind of expressed in this figure that is white. Oh, there is only background, because that's all that ggplot knows at this stage about the data set. So the next step is to define some aesthetics, which is a mapping from our variables to the axes, or the features, aesthetic features of our graph. So for example, if I would like to visualize the log2 intensity intensity on my y-axis and my categories that are wrongs on my x-axis, I need to define, so these are variable name column names in my tidy data set, and they are now automatically mapped to my x and y axes. But in addition to that, what also happens is that ggplot2 now realizes what kind of values we have here. So the wrong is a categorical variable. So I had 12 different wrongs, so I have 12 different ticks here on my x-axis, and log2 intensity is a continuous variable, and so ggplot2 will adjust the scale accordingly. And the last step here is now to eventually materialize this visualization. We know what we want to map, but we need now to express how we would like these data that are on one axis categorical, on the other one continuous, how they should be visualized, and this is done by defining a geometric object, box plot, and eventually now we get the figure we want. And you will then adapt your geoms depending on, of course, your mapping, but depending on the visual representation you want to obtain. Okay. So I'm going to skip. I'm going to show it. It doesn't cost much, just to make sure that this is present for the exercise later on, but we can also overlay a set of geometrical objects, and in this case I start with a jittering, and so that's the object, the geometric object that is plotted first, and on top of that I overlay a box plot. Use exactly this. And arguably the most powerful feature, I think, of ggplot2 that was not invented by ggplot2, that was already available in R for a long, long time in the lattice package, is faceting. And so I can here facet grid, for example, to produce different subplots based on the condition. Exactly what I wanted to see. Picture one now. let's use here tag. Something that is slightly more meaningful. Here, where based on the faceting defined in facet grid, I will have the appropriate subfigures. So as opposed, for example, to base graphics, ggplot2 most certainly has very decent defaults for the colors and so on. But if you are in need for other colors, for better colors, there are two packages of interest here. Veridis and our color brewer, and in particular, our color brewer provides these palettes that can be used depending on what you want to visualize. If these are kind of discrete categories, kind of a spectrum with different colors. So these are specific color palettes that are provided, and as far as I know, have been developed, and there might be there probably is additional research on this topic. But these were developed specifically so that the kind of, information that these colors convey is maximally useful. And so these are the names of these different palettes that you could reuse. And so, for example, to provide another example, the Veridis color scales. CRCDF. Let me just check that I have this data. Yes, and I'm going to come back here, CRCDF. Move it to this script in case you need to load it again. So here I pick two columns, two genes of interest, and for example, if I wanted to find my color here, the color would be based maybe on this other gene, G, plus G, so this would be the scatter plot. So here I have stored my variable, my figure in my variable P. Here, and if I now want, for example, to change the scale, I could use a scale, color. The brewer colors are already available, or here. To adapt my scale, depending on what the needs are. So there are several other examples in the notes using this Veridis. I'm not sure if that's how I'm supposed to pronounce it in English. Anyway, yes?
So when you execute that max CRCTF using the parentheses outside, what does it actually do within the parentheses?
This one?
Yeah.
So it uses the read underscore CSV.
Like we did before for IPRG reading it. And then we already have the object IPRG, right? When we read this whole data set in IPRG.
Yeah.
And then when we are doing the CRCTF within one parenthesis.
So why it's within parentheses?
Right.
Yes.
What exactly is it?
Yeah, so if I run it like this, it's going to create or overwrite my variable. If I add it in parentheses, it's a way to say create a variable, but also print it out. If I rerun it now, it executes the line of code, it creates or overrides a variable, and then it also prints out the variable. You see? So I don't need, so this here with parentheses is equivalent to running it and then displaying it. And so very often when writing material, I think it's easy to have parentheses and then it gets displayed automatically.
So we already had this in IPRG, right? This whole data set. What's the reason that we are creating another creating CRCTF?
So this is another data set. This is the CRC data set, and that's the IPRG data set. That we actually already also had this morning. So this same line of code, we already had it this morning.
Sorry. Okay, so I got it. I thought that it's.
Yes? Oh, so this is the mapping that we do. So these names correspond to variables in this CRCDF dataset, and in this case, these are gene expression values for 200 samples. We can have a look here, CRCDF. Paste data set, so 1, 2, I picked the 3 first ones. And so we have 200 rows, each row corresponding to a sample. And again, here it's kind of easy, if that's exactly the kind of visualization I want to do, but if I wanted to have a notation about these samples, I would need to look at column 73, column 2, 74. Or reformat my data set in a way that is slightly more convenient. So there is a section about customizing plots. I'm going to skip this and have a look maybe in the notes. There are an infinite number of ways to customize figures, of course. But something that is maybe new to you and I think actually very useful is a package called Patchwork. And I'm going to cheat and I'm quickly going to do some copy and paste it to quickly create 4 plots. Here, so here I have some ggplot code that's going to create 4 plots. And here, so a box plot very similar to what I did before, condition and log2 intensities. With some theming, so that's how you can customize your figures. And here I want some coloring based on the condition. The second one is scatter plot, intensity against log2 intensity. Always using this, reusing this IPRG figure. Here I use some grouping by and some counting. How many technical replicates and bioreplicates do I have in IPRG dataset? And geomcol, I don't remember.
Geobar with stat identity.
Pardon?
Geobar with stat identity.
Okay. That's here. Oh, it is. Okay, yeah. count exactly. Well, yeah, that's what I want to do. I want to count for my 3 technical replicates the different bio replicate, and then the 4th figure with the violin plot. So let's say I have these 4 figures, and now I want to compose these 4 figures into one larger figure. And package grid.extra has some functionality, but patchwork is, I think, pretty elegant. And so, for example, if we wanted to combine P1 and P2, we could simply type P1 plus P2. So reuse the ggplot addition operator. And the computer is sometimes a little bit slow. So normally, yeah, it's still, oh, no, that's not what I want to see. Here. So this was my P1, this was my P2, and it's automatically going to align P1 and P2 next to each other. P1 plus P2 plus P3 plus P4. This would produce the 4 figures next to each other, but I could also define a plot layout and say encode equals 1. And now the figures would be not plotted next to each other, but on top of each other with a single column. Not sure. Let's try with n column equals 2. Okay, I'm going to stop with this patchwork with the computer. Oh.
Can you go back to the code where you installed patchwork?
Yes, sorry. Where I installed patchwork, yes. It's here. And if you don't have, do you have Faceting Manager?
Yeah.
Okay. Oh, so here we go, and this here, so I have P1 plus P2 plus P3 plus P4, but this has been set up on the layout with the 2 columns, and so on. And there are, I'll let you run the different examples. There is an interesting signal. Let me try the last one. Here, P1 or P2 or P3 or P4 plus plot layout. Oh. Line here. Plus P4. Oh, sorry. We should have the 3 first ones and then the 4th one elongated or very wide below. So the patchwork GitHub page has examples of how you can compose relatively complex figures with the plus, the pipe, and the divided, and so on, and defining the plot. Maybe this will appear at some point. So do you want me to leave this screen on for a little bit? So my suggestion would now to move to exercises. And I've prepared a set of exercises. So if you go on section 5.8, there are, I think, 4 exercises. So the first one is to use the Anscombe dataset, and it's readily available in R. Suffice to type Anscombe, and you will have it. But you will see that it's actually a pretty horrible format, or at least in terms of data analysis and data. Oh, here it is. So this is the figure that we get with this syntax. Okay, three first plots in the first row, and then we move to second row. So a data that is, or format for data that is maybe very convenient to look at it, and clearly whenever people show you this data set, that's exactly how they show it, with the axis 1 to 4 and the y's 1 to 4, maybe with the x1, y1 next to each other. But that's not necessarily a figure that is the most convenient, and certainly not if you wanted to produce a figure with ggplot2. So the first exercise would be to reproduce this figure. But with ggplot2. And so the first thing that so here we have x1 versus y1, x2, y2, and so on, and then add a linear model. You can use the geom smooth for that. But before being able to do that with faceting, or you could actually also maybe do the 4 figures and then use patchwork to combine them. Why not? But otherwise, if that would be your data set, you would need to retransform it to get a long data set. And I think it to ggplot2. So that would be your first exercise. And I'm going to walk through the different exercises, so people that want to go on can do all of them. So here's another one where now we want you to count the number of proteins that were quantified for each group, gender, age, and visualize the results. So that's a CRC data set. And for example, here's a way where you might want to visualize this, where with faceting, the faceting is done based on the status, CRC or healthy. Inside here, we would have for CRC female male, healthy female male, and here we would count how many observations, how many proteins have been quantified, and then here the different colors would represent different age categories. I'm not sure if that's maybe not the best way to color code it, because there is a scale, but that was the default that ggplot2 produced, because these categories were defined as concrete categories. It's not a continuous variable. So this would be an example that would allow you to go through grouping, tallying, and ggplotting, and faceting, and things like that. Okay, tallying, and then here to create the age categories, I'll use the count variable. So another example, again, maybe not the nicest one, but the idea is to go through different capabilities of this DeepPy and ggplot2, look at the expression values of a certain number of genes for these set of all the genes for all the samples that start with P1 something, and then do some faceting for male and female, and then at the top we have again CRC and healthy. and it produces this weird pattern, but clearly that's not something that we would have been able to see. Maybe it's not the nicest figure, but clearly that's not something we would have been able to see by staring at the table. Slightly more data pre-processing. Here we have two samples, P1A10, so still CRC, P1A10, P1A2. And what we do here is a scatter plot to look at the intensities of all the 200 samples. But we have added two additional variables. The size of the dots is reflected by the average intensity across all the samples, for all genes. And then here we calculated a fold change between the CRC and the healthy. The two groups, the same groupings that we used beforehand for the faceting. So 4 exercises that will give you plenty of opportunities to walk through the different material that we have seen very briefly here. Okay. So if dplyr and ggplot, if you were not too familiar with dplyr and ggplot2, feel free to call me, and then we can. I'll give you maybe 5 or 10 minutes to do the first one. So could you maybe use your green sticky note once you have done the first exercise? But that shouldn't stop you. Just keep on. And in the meantime, if you have any questions you would like to, if you have any specific questions about the material that you have seen, please don't hesitate to call me. And then we'll go through these exercises one by one altogether. Okay. Should we look maybe at exercise 1 together, or do you prefer to work on your own pace? And I don't see any any green sticky note. So as far as I'm concerned, I can sit down there and wait. But it's really up to you what you prefer. I'm sure some people here are really knowledgeable, so maybe you have done all the exercises and you are ahead and you do something else. But maybe some people would like to walk through the exercise one by one. But I cannot figure out without information from you. So shall we do the exercise 1 together? Okay. Good. So here is exercise. So here's the starting data that we have. And so one way that I find useful when I have similar kinds of problems is to think of what do I want to get. Okay? And so it's pretty clear here what we want to get. It's these kind of scatter plots, right? 7 points, and then eventually we want to have a line. We want 4 of these plots. We will want to use ggplot2. So to produce the figures, it's g on point. To produce the line is g on smooth. So that's just kind of the easy part. Producing the final figure, that's our analysis, modeling, and this is actually trivial to do. What I think is not as trivial is how can we produce the data so that we can just do ggplot2 data equals blah blah, mapping the axis using g on point, g on smooth, and faceting. And so how should my data look like so that I can feed it in straight away to ggplot2? Okay? So I will need observations and variables. That's always the case. But what should these variables be? What do I need to have? Okay? Don't forget. So if we look at, here, okay? Here is exactly the kind of code that we want to run. We will have some additional geoms and faceting. But this is exactly the kind of code that eventually we will want to run. We will have a data set, and then we will want to do some mapping. So what will we need to do? What kind of mapping will we need to do? And if we know that, we know what the data will look like. Okay. So does anyone have an idea? What?
Epsilon
Pardon? Sorry, that will not be. I forgot the microphone. Oh dear, oh dear. Sorry, x1. Yes, so that is x1 versus epsilon 1. Yes, you're right. That's the kind of final output, x1, y1, right? We have 10 pairs of points. But to get there, can you tell me what the names of the variables need to be and what data do we need to have to fill in? Pardon? X? Okay, yes. X, like this. Okay, anything else? So would I then, so for my first data point here, what kind of values would I have in X and Y? Because I have many X's and many Y's. So if you pick, let's say, 10, one here, and 8.09. 10, 8.09. So that would be one observation. And then there is also a 10 and 9.14. This is another observation. But they are different, right? They are not part of the same series. So I need another variable that will tell me, is it part of the x1, y1, or is it part of the x2, y2? So some information that is not here, or that is kind of implicit, is that we have 11 points per data set. And some other information that is not encoded directly is that we have one series, second, third, fourth. So we would also need something that tells me this is a point of group 1, this is a point of group 2, and so on. Okay. And this I will then be able to use with faceting. So I'm going to create a new script here. Say it has S3. Tidyverse. And so here is my data. And so I want to get something like this. So does anyone have a suggestion of how I'm going to transform this data into the table over there? That should have 44 observations. Gather, yes, okay. Do you have one way to gather everything in one go?
My method was gather one point, capital P point, next would be value, would be the values of the matrix, and then minus point, how to name the.
Okay, so you want to first create a new variable?
So take Anscom.
Yeah.
So Anscom, the I function,
Okay.
and then gather capital P point, column. And value, capital P value, and minus point. Everything except for the points. Oh, wait, that there. I don't have RStudio on this computer, so I'm doing this in Notepad. Then, yeah, he would need the whole thing.
Let's see, I'm not sure what this is going.
Just remove the last argument to that.
Oh, okay. Okay, I see. Right. So now we have two columns, one with all the values, but this value x1, so here we have all the values that were in this x1 column, all the values that were in the x2, okay?
So then you need to split the x and number, and then you need to spread. I took a group nest spread nest strategy.
Okay.
Eight.
Okay, so you create this long data, and then you want to split it based on points.
Yes. So
Okay.
mutate, and then if I mutate.
I suggest. Is that okay?
Of course.
There's probably a better way of getting there. So, okay. Series number. Okay. So, getting there. But what we want to have is the variable column spread into x and y. So to get there, you can group by series number. Nest. Uh-oh. I might skip 10 steps. Is there an easy way to just make a vector of length? 88, just 1 to 88, so each one has a unique ID. Well, actually, no, you wouldn't do that.
Say we want to
Keys are shared by 22 rows.
I think it's, I think that, at least personally, we get beyond my familiarity with the tidyverse, where we start nesting, and then we use kind of special variable .x and the tilde here. So, personally, I think this becomes personally, I think this becomes really complicated, and it's certainly, I'm sure, I mean, you know what you're doing, and you will get it done. But in my opinion, this becomes a kind of a really difficult problem. It's supposed to be simple, but it's not. Unfortunately, the things that look simple, at least when we look at it, very often they become complicated. So maybe what I would suggest, could you post that on Piazza? Because I think it's beyond what we're going to see here, but that uses some advanced functionalities of the Tibbles and dplyr. So I think it would be really good if you could post it on Piazza so that everybody sees it.
Okay, I'll clean it up first.
Yeah. But thank you, okay. So here we also use some functions that we haven't seen, where we extract from the new variable points either the digits or the letters. Okay. I have a much more down-to-earth, not as elegant version. But first, does anyone have another possibility? Yes?
So we create 4 different objects, say like just like P1, P2, P3, P4, and then plot them together with the plot layout function.
Okay, yes, absolutely. That's called getting things done. We create 4 plots, P1, P2, and then we do P1 plus P2 plus P3. No, absolutely. And I have 2 more exams. Every student comes with that answer. Unless I said you are not allowed to do it, that's really, absolutely, yeah, definitely. So I'll try to slowly build that data set. So that's what I'm aiming for in my case, okay? I know that I want to have this figure, so somehow I need to get this data set. So that's what I'm going to aim for. And I'm going to do step by step, okay? So the first thing I'm going to do, and I have to be honest with you, I am not sure if I absolutely need it, but I'm going to say point 1 to 11. Okay. So I'm going, and I don't need my plots for now because I'm not there yet. I'm going to add this column points. I am not sure if I need it, I probably don't. But this is some information that is going to be lost when I start to transform my data. So I want something to record this information. So here we are. So I have so far only updated my data and have added this information. It doesn't matter whether we are first or second in the series, as long as my axis xi and y's, x's and y's are together. But this is data that we know how the scatter plots look like. If this was some random data, I didn't know whether I was expecting a linear correlation or not at all. If I mess up my relationship saying that this x1 or this x matches this y, I might end up with a cloud of points and impossible for me to kind of check back whether this is correct or not. So the first thing I want to do is to add these data. Okay? And so I'm not going to create 4 different sub data sets, but I'm going to create 2 of these. I'm first going to look at the x's and the y's because I will want to have 2 columns. One with all my x's and with all my y's. And that also allows me to use one of the functions that we had seen before, which is gather. So I want first to look at columns 1 to 4. These are the ones, and actually I'm going to create here a subset with all the x's. Okay? So first data set with all the x's. So I want to gather these, and I want to do the following. To produce this data, where I have something I call coordinates. And here I remember that these first set of x belongs to x1, the next set of x belong to x2, and so on. And here I have the value. And then I'm going to do the same thing with the y's, but this time I need 5 to 9, and in this case my value will be y, and I say minus point. And here are my y's. And again, just to be on the safe side, I keep my points. Again, I might not meet them at all. But at the end of the day, if I generate a plot, nothing looks like a scatter plot than another scatter plot. And unless I know I have a specific relationship, I want to be on the safe side. Okay? And so what I do now is I'm going to manually c-bind. So take my x's and my y's, these 2 kind of small data sets, and combine them. So here, okay, my axis, I'm only interested in my second column. The first one, well, actually, I can probably just do all this. I'm going to c-bind my x's and my y's, and I'm going to pipe this into an S table to make it slightly easier to look at. Does it complain? Okay, so I need to drop the points. Okay, so here we go. That's my original axis. Yeah, but I only kept the second column because point was already present, and apparently this cbind complaints. And this is my second data frame that I created with all the Ys. And so now I can use this. Any questions about this? Yes? Yes. Okay, let's see. Does it have to be? So if I have, right. If I say x and I say, for example, only one column, it's going to simplify my data structure instead of returning data frame with one column. And so here, if I say drop equals false, it's not going to just do the simplification, and it will not drop the additional dimensions. So let's see. What if I only say drop? Maybe that works too. Okay, it's fine. I don't need it, but I find this name horrible, so maybe that's why I left it. And let's see, is this related to the Tibble? Yeah, okay. So I find this really annoying, this name, because that's something that I will need to feed into ggplot2. So I will keep my drop. So now I have my x and y coordinates, and I have this chord, possibly not the best name, but remembers whether it was a y1, y2, y3, and y4 group. I don't have the x1, x2, x3, but these are equivalent. So now I can take my statics, x equals x, y equals y, plus g on point. So here I get all my figures overlaid one on another. Maybe I'll want to add some color. Color equals. I want to do some facet. Wrapping here. So here I have my four figures, my 1s, 2, 3, 4. And then to add my linear model, I can use the geo smooth with method equals lm. Of course, if you are not familiar with these geoms, that is something that you would need to look up on the ggplot2 webpage, but they have these little graphs, little figures that I always want to very quickly, if you have a mental idea of what you want to do, you can quickly look at the images and find the possible geom that would fit the bill. So, C7, so we can ignore this one because I think point is not needed. So 6 lines of code to produce this figure. I think to try to produce this figure from the original, how many lines of code do you have where you created the 4 different ones? 46.
More than 6.
Oh, more than 6. Okay. Oh, sorry. With your analysis, but you know, it's kind of elegant. Sometimes it's really nice to use the cool features when you know them. But you.
Right, it's 3 lines each, so 1230.
Okay. So if you repeat the same block, maybe there would be room for write a function. That was, yes. Okay. But maybe we are starting to over-engineer something that was supposed to be very easy. But again, very easy conceptually. I certainly don't claim that this is easy code. I think it requires a little bit of thinking. And my way to get around, to make the thinking is actually the most difficult thing, as opposed to writing code. But to make the thinking easier for me personally, I found it useful to write this and think this is the figure I want, this is the data frame that I will need, and so I focus on my x's and y's and something to record where the pairs come from. So that was my line of thinking to write this. And again, certainly not trivial. I certainly don't think this is trivial, even though the exercise as such produced 4 scatter plots isn't difficult. Well, isn't supposed to be difficult, but. Okay. Did anyone have another possibility? Yes?
I have it in one pipe, but it's, I guess, computationally not very efficient.
That doesn't matter. I mean, whether it takes half a second or 1 second, it's not going to make a difference for me. Now, if it takes 1 hour instead of 1 second, that's a completely different story. But, so you have one pipe and you did do everything?
Yeah.
Do you want to come and show us?
Yeah.
Okay, don't forget that the current Anscombe has one additional, it might not matter.
What?
The current data set Anscombe has a point column. It might not matter.
Yeah, that would matter, I guess.
Then just type data Anscombe and then you're going to overwrite it. Okay. But this line is only to get rid of what I created there. Interesting. So once you have finished that line, could you execute it?
Yeah, so that was just my initial thinking to do this together once for x and once for y. But then I noticed that it's really not very useful because it gathers like x2 together with y4, and this is a point that's not even valid. It doesn't.
Yes.
It doesn't make sense.
Can you just move up and look at the top? Okay, so it makes all the x-y combinations. x1 with all the y's and. Okay.
So that's not what we want. So I have to filter for the ones that are for the combinations that are just the right ones. So like the x column.
Oh, I see.
Found it. So now it's only the valid ones.
Okay.
x4 and y4. And I think now you can plot it.
Yeah, now you can feed it immediately in GG.
Yeah.
Okay. That,
Yeah.
okay.
Then the same.
So can you start equals 2? Can
So-
you explain us what these two do?
So you take the whatever it is, x4 and so on, and you just take the numeric part, which is interesting. So you you say take a subset of the string, which is this kx. So in this case, for example, x4, and start only with the second character. So it would select the 4 here, and then it would do the same for the y. So it would also select only this y, and then it would compare if it's identical. Yeah.
Okay.
So the table is then filtered for those which match this case.
Thank you. Anyone has another option?
Can you try running hard one more time now that it has that point?
Pardon?
Added? Can you just try rerunning the pipe that I made? Now
Yes.
that it has that point 11? And not.
Run this, just as it is.
Okay.
So as you can see, very simple exercise compared to the high throughput biology, the real difficult science that we do, but already plenty of opportunity to innovate. Okay. So I think we are supposed to do a break now, unless you want to check and write the slides. Otherwise, my suggestion, all the answers are already available in the lecture notes. What I suggest is there is a Q&A session at the end of today at 6, although I think 6 is already pretty late. But so tomorrow we can start at 8 o'clock. Are you happy to start at 8 o'clock? Yes, I see everybody's really excited to start at 8 o'clock. So we will start at 8 o'clock. I kind of hope people would say. But, so I will be here at 8 o'clock, and my suggestion is, unless you have other questions related to the course, or maybe some applications to your domain of expertise, maybe at 8:30 or so start by going through other of these exercises altogether, so I can kind of explain what I did, but the solutions are already there. Okay, so I'll be here at 8 o'clock, but maybe at 8:30 we'll start by, or earlier if there is demand for it, start to go through these exercises altogether. Okay? Right, well thank you very much. Let's have coffee, and then we have a really interesting talk that is kind of orthogonal to the things we have seen, and we see how to produce kind of visually appealing and useful figures.